Your HDMI isn't broken. It's just doing high-speed data like a sprinter on gravel. Welcome to the beautiful, brutal physics of TMDS signaling. Transition minimized differential signaling sounds like a fancy car part, but it's actually just two wires carrying opposite electrical signals. When noise hits, the receiver subtracts them. Perfect cancellation. But only if the wires are perfectly matched. And that's where your wallet starts bleeding. To keep that cancellation tight, you need precise impedance control, usually 100 ohms. You get that with braided copper shields, aluminum foil layers, and dielectric spacers. But add all that armor and the cable becomes a stiff garden hose. So manufacturers compromise. They thin the shielding. They use cheaper plastics. And suddenly your gigabit highway turns into a dirt road. Then version bloat hits. HDMI 1.4 gave us 4 kilobyte resolution. HDMI 2.1 demands up to 48 gigabits per second. That's not a bandwidth upgrade. That's a physics crisis. Higher frequencies mean the signal crowds to the outer edge of the copper. They call it the skin effect. I call it thermal suicide. When current hugs the surface, resistance spikes. Heat builds. The dielectric insulation softens. Microfractures form in the traces. Latency jumps. Signal-to-noise ratio tanks. You see it as green screen artifacts or audio dropouts. Engineers see it as a pacing mechanism. The cable isn't failing. It's throttling itself to prevent total data collapse. You plug it in, you unplug it. The metal contacts wear down. Oxidation creeps in. The impedance wobbles. And suddenly your setup needs a handshake reset. That's not a defect. That's structural stress doing its job. High-speed transmission demands sacrifice. You can't run a fiber optic race in a copper trench and expect the trench to stay pristine. Here's the controversial part. Degradation is a feature. It forces periodic upgrades. It keeps the supply chain breathing. It prevents monopolies from sitting on a single cable design for 2 decades. You're not paying for a product that lasts forever. You're paying for a controlled burn that keeps the ecosystem alive. Now, I know what the comment section is already typing. But my $10 cable works fine, cute. You're experiencing a skill issue. Your setup probably runs at 60 Hz with no high dynamic range. You're not testing the cable. You're testing your own low expectations. Physics doesn't care about your budget. It cares about bandwidth density. Let's loop back. We solved shielding. We introduced dielectric loss. We solved dielectric loss. We introduced version mandates. We solved version mandates. We introduced thermal efficiency limits. It's a beautiful, chaotic curiosity loop. Every bottleneck breeds a new spec. Every spec demands a new cable. The cycle is the product. The bitstream doesn't lie. When TMDS sync breaks, you get macro blocking. You get audio desync. You get that glorious blue screen of death. It's not magic. It's math. And the math says your cable is a temporary bridge, not a permanent monument. Accept it, upgrade it, profit. So stop blaming the cable, start blaming the trade-offs. Every inch of copper is a compromise between latency, shielding, flexibility, and cost. You want a cable that never degrades, build it out of diamond. Good luck fitting that through your wall plate. This is tech validation, not conspiracy. The industry isn't rigging your TV, it's rigging the physics, and honestly, it's working. We get sharper images, faster refresh rates, and audio that doesn't sound like a dial-up modem. You're paying for progress. Just don't pretend it's permanent. Drop a comment if you think copper should magically carry terabits for decades without sweating. I'll be down here measuring impedance with a multimeter and laughing. Subscribe for more chaotic engineering breakdowns. And remember, if it doesn't degrade, it's not high speed. It's just a wire.